Hi everyone, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. And so sorry for the delay. Actually, my system was in auto update mode. That's why it got delayed. So yes everyone, how are you all? How is your NEET preparation going on? Everyone in the chat box. Yes. So today we are going to start physical chemistry, that is some basic concepts of chemistry. Today we are going to start with this first chapter of your class 11. Okay, we are going to take up everything in a basic manner to advanced manner. So physical chemistry, usually students, what they do, they take this chapter very lightly because they feel that okay ma'am, not many questions come from this chapter. But in this chapter, basics will be cleared, right? There will be atomic mass, gram mass, what is the difference between different atomic masses, what is mole concept, right? Mole concept is applied in your entire physical chemistry, so you must have knowledge about mole concept. There are direct questions in your NEET regarding empirical formula, limiting reagent, two most important topics, and we have laws of chemical combinations, right? So these are the topics that we are going to cover today. We are going to complete the whole chapter today itself. So everyone ready? Is everyone ready? Everyone in the comment section, are you all ready for the start of physical chemistry? Yes everyone. Chemistry board is on 12th boards, which all the best bacha, all the best for your exam. Saath, do best, and yes, you will definitely succeed in your exam, right? The hard work that you are doing will definitely pay off. Yes, okay, perfect. In chemistry board exam, thank you so much bacha, thank you so much, and I wish you all the best for your physics paper, for your biology paper, and for those who are covering physics, chemistry, bio and maths, all the best for your all exams, right? Okay, yes bacha, yes, okay. Josh is high, okay, Josh is high. Okay, so now we are going to start physical chemistry. Now, there are few things, okay? Let us talk about matter. Shall we start, everyone in the comment section? Shall we start? Yes, because all the students who are preparing for board examination, I don't want to waste their time, right? It will be a very short lecture. I'll complete it within 2 hours, right? Whole chapter within 2 hours with question practice and examples. Yes, bacha? Perfect. Okay, so let us start. So first thing that we have is atom. We have that matter, right? Matter, everything around us is matter. Everything around that has space, that has volume, everything around us is matter. So in that matter, you have atoms, right? The tiniest particle, that is called the atom. So the first theory that was given by Dalton's, that was the atom is indivisible. So what is atom? Atom itself, the meaning of atom means indivisible. Firstly, it was assumed that atom cannot be divided, but after that, that theory got ruled out. Right now, the theory is not correct. We will study the structure in the second chapter, that is structure of atom, right? That we are going to do after this chapter. Now, let us talk about the physical quantities, physical entities of atoms here. Okay, first you have atom, that is by Dalton's atomic theory. We know that what is atom? It is the tiniest particle. Matter made of extremely small particle, that is called atom, and that means which cannot be divided further, which got ruled out after that. Now, talking about atom, you have few things here, okay? You have few things here. First is 1 AMU, that is atomic mass unit. So now let us understand what is atomic mass unit. So, for example, what they did, okay? So there is a theory related to this, that firstly they took H atom. Now, if you want to compare, because atom is very small, okay, very small. So, how to calculate the mass of the atom, right? Slightly tilted, left side, is it? I'll do that after the class, okay? Yeah, okay? Yes, I'll do that after the class, okay? In the next class, that won't be a problem. So, now, you have atom, you have to calculate the mass of that atom. Now, that is very tiny. To calculate the mass of the atom, it was nearly impossible. So, to calculate that, we have to compare something. We need to have some unit that can calculate, okay, because we cannot calculate the smallest, tiniest particle mass in grams. So we need to have a different unit, otherwise it will be in so many fractions. So now we need to have a new unit. That new unit is 1 atomic mass unit. And 1 atomic mass unit is in comparison to some atom that is already existing. So firstly, as we know in electrochemistry, we take hydrogen as the relative thing, right? So firstly, they took hydrogen as the relative thing, okay? That we will compare. Now what happens in the class? We compare toppers with everyone, right? Then we decide who is the topper, who is the average, who is not the average student, who do not study at all. We have some set, okay? Who is carrying, who is having 90% is like above average, who is between 80 to 90 is average student. So same way, defining the atom here, we have to have some atom that is the standard. Firstly, they took hydrogen as the standard, right? Then they took oxygen as the standard. Then finally they took carbon as the standard. Now the main thing here is that, ma'am, if they take hydrogen atom, then what was the problem? The problem in taking hydrogen atom was that the masses were in fraction, because you know it is such a small atom, it has very small mass, so everyone else masses is coming in fraction. That was the problem here. So that way it was neglected here. After that they took oxygen. Now we have two main isotopes of oxygen, that is oxygen 16 and oxygen 18, right? They forgot to mention that they are using oxygen 16 here. So different countries, so many places, someone is using oxygen 16 as the main standard, someone is using oxygen 18 as the standard. After they clarified also that oxygen 16 is the main standard, but that was ruled out because of so much confusion there. Now third atom, they took carbon, and it also has so many isotopes, carbon 14, carbon 13, carbon 12. So now they mentioned that we are taking carbon 12 as the isotope here. Carbon 12 isotope is taking as the standard. So now it was fixed that we have to calculate 1 atomic mass unit taking carbon as the standard. So now what they did, how they calculated the standard. For example, you have an atom, you have a box, okay? You have a box, okay? You divide this box in 12 units, okay? You divide this in 12 parts. You divide this in 12 parts, okay? You are dividing this in 12 parts. So I am dividing this in 12 parts, and I am taking out that one part here, okay? I am taking out that one part here, and this is the 1 AMU. That means if I have a box, okay, let me talk about this marker, okay. I have this marker, okay, I have this pencil. So now what I'll do, suppose this is carbon 12 isotope. So what I'll do, I'll say 1 atomic mass unit is, I'll divide it into 12 halves, okay, I'll divide it into 12 halves, and I pick that one half. For example, you have one cake, or you have one pizza, okay? So pizza we usually divide it in 6 halves, right? We have that pizza, we divide it in 6 halves. We have a pizza, we divide it in 6 halves here, okay? I don't know how it is divided. We usually divide it like this, right? Is it? Yes? Okay, we have medium pizza, we are dividing in 4 parts. So this one part is, I'm calling it, this is the 4th part, okay? This is the 4th part. Same way, I divided carbon 12 atom, I divided that atom into 12 halves, and I said 1 AMU is the 1/12 of that carbon 12 atom, okay? Then we have one carbon 12, we have one carbon 12, and I'm dividing it in 12. 1, 2, 3, 4, 6. Now this is 1, 2, 3, 5. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is a carbon 12 isotope. This is carbon 12 isotope, right? Okay, this is carbon 12 atom. I have divided it in 12 halves. So what I will write, 1 AMU equals to 1/12 of carbon 12 isotope, carbon 12 atom, right? So this was the main thing here. So now I have defined 1 AMU. 1 AMU I have defined here. Okay. So same way we will calculate. Okay. Same way we'll calculate 1 AMU, and I'll multiply all the atoms by 1 AMU. right? Okay, so atomic mass unit is equal to 1/12th mass of one atom of carbon-12 isotope. This is the first thing. Now, after calculating, so now what is the mass of, this is experimental thing, okay, this is experimental thing. After calculating mass of one carbon-12 atom, right, they calculated the mass of one carbon, they put the value here, and 1 AMU turns out to be 1.6 into 10 raised to power minus 24 grams, right? This is 1 AMU, this is 1 AMU, right? This is the value of 1 AMU, right? Okay, now next thing is, ma'am, what is the difference between, we have 2-3 masses here, right? We have 2-3 masses. One is atomic mass unit, one is gram atomic mass, and the other is molar mass, Now ma'am, what is the difference here? How we define all of that? Okay, so see, atomic mass unit is the mass of any atom. If we have carbon, hydrogen, nitrogen, oxygen, if we are talking about any atom, the mass of that atom is called one atomic mass unit. Okay, suppose we are talking about oxygen. Okay, I am talking about oxygen atom. The mass of one oxygen atom, this is the mass of one atom, right? Okay, gram atomic mass, this is the mass of everyone. Wait, I don't have space here. Okay, gram atomic mass is the mass of, 1 mole. Okay, if I am talking about 1 mole means 6.022 into 10 raised to power 23, right? This is 1 mole. If I am talking about molar mass, again it is the mass of 1 mole. Right? Okay, and here if we talk about the difference here, the numerical value is same. If I am talking about one oxygen atom will have mass equals to 16 U. Okay, here we are represented by U, right? And for gram atomic mass, this will be 16 gram, and for molar mass it will be 16 gram per mole, right? Okay, that is the difference only. Here also we can write gram per mole. Okay, here also we can write gram per mole. The numerical value here will be same. There will be difference in the units. Okay, the numerical value will be same. For example, I am talking about here, if I am talking about oxygen atom, let us take nitrogen atom. If I am talking about nitrogen atom and I am talking about N2 molecule, right? This is N2 molecule. This is 1 mole of N atom, right? I am talking about 1 mole of N2 molecule. So everyone, what is going to be the answer here? Okay, right? Okay, very basic thing here, right? Okay, what is going to be the answer? One nitrogen atom, I will say this is 14, right? Okay, 14 U here. One N2 molecule means I will say 14 into 2. Okay, 14 into 2. That is 28 U here. Okay, why U? Because I am talking about one atom or one molecule. Now when I am talking about 1 mole, I will write it 14 gram per mole, or I will simply write 14 gram. When I am talking about 1 mole of N2 molecule, this will be 28 gram per mole. Okay, or I can simply write gram here. Okay, same thing, either I can write gram or gram per mole, that is the right thing. Okay, this is the thing, right? That is the difference between atomic mass, molecular mass, gram molecular mass, all these things. Okay, yes everyone, understood? Yes. Okay, very simple, but usually student gets confused in this very basic thing. Now let us talk about Avogadro's number, right? Avogadro's number is what? 1 mole. Okay, what is Avogadro's number? Avogadro's number means I am talking about 1 mole of particles here. That is 6 into 10 raised to power 23 particles. That is called 1 Avogadro's. Okay, for example, we assume that in 1 dozen we have 12 bananas. Right? That's our assumption. In the same way, we assume that 1 Avogadro's, that is represented by Na. That means 6 into 6.022 into 10 raised to power 23 molecules or atoms. For example, I am talking about hydrogen atom. Hydrogen atom. So for hydrogen atom, in 1 mole it will have 6 into 10 raised to power 6.022 into 10 raised to power 23 atoms. Okay. If I'm talking about H2 molecule, it is going to have 6.022 into 10 raised to power 23 molecules, not atoms. Okay, it is going to have 6.022 into 10 raised to power 23 molecules. And if you calculate the atoms here, that will be 2 into, because in one molecule you have 2 atoms. That will be 2 into 6.this into 23 atoms here. Okay, right? If I am talking about oxygen atom, right? If I am talking about calculate, for example, I am writing here, calculate atoms here. Atoms in the following, right? You have to calculate atoms in the following. The first part I am talking here is, that is oxygen, right? Oxygen, 1 mole of oxygen atom. 1 mole of oxygen atom. Second is 1 mole of ozone. Next is 1 mole of oxygen molecule. Right? Okay. So now we have 1 mole of oxygen atom. We have to calculate the atoms here. Avogadro's number, you can simply write Na here. Right? 1 mole, that means I am talking about Na atoms here. Okay? Na atoms here. Right? Number of atoms means particles here. Okay? Right? 1 mole of ozone. Ozone means O3. O3, we say it has Na of O3 molecules. It has Avogadro's number, that is 6.022 into 10 raised to power 23 O3 molecules here, right? But if we want to calculate the atoms here, that will be 3 into Na of oxygen atom. If I am writing here O2 molecule, that will be Na of O2 molecule, right? But it will be 2 into Na of O atom, oxygen atom, right? Okay, simple? Yes, very basic thing here. Now, if you know these basics, mole concept is going to be very easy for you, right? Similar way, we see atoms, we say molecules here. So Avogadro's means here, that doesn't mean we are talking about, Avogadro's does not mean that we are talking about this much atoms or this much molecule. Avogadro's means we are talking about 6 into 10 raised to power 23 particles. That particles can be a molecule, that can be an atom, right? Okay, so this is referred to Avogadro's number, and how it is calculated, how it was defined here. This is not so important for you. Importance for you is how do you understand that, okay? Not how it is derived, okay? But still, number of atoms, that will be equal. So I'm talking about total mass, that is 12 gram, okay? If we talk about the total mass of carbon, okay? That is total mass of carbon molecule here, carbon atom, that will be 12 gram, right? Divided by mass of 1 carbon 12 atom, that is 12 AMU. And you divide it here, you will get 1 by 1.16 into 10 raised to power, because the numerical value for AMU is 1.66 into 10 raised to power minus 24, divided here, and you will get 6.022 into 10 raised to power 23. But the derivation is not important for you, okay? That is not important, that is not asked in your syllabus, okay? Now next is, what is relative atomic mass? Relative atomic mass is how you define, that is relative atomic weight is expressed as mass of one atom with respect to a fixed standard. Okay, that we have calculated everything with respect to that carbon 12 isotope, right? Okay, next we have bacha, that is relative atomic mass is equals to mass of one atom, and this we have calculated this, okay? That is nothing but to compare something with, okay, we are comparing every atom with carbon 12. That is called relative. Okay, that is we are talking about. These are not the absolute masses. We cannot calculate, we can't say carbon, we can't say nitrogen have absolute mass 14. It does not have absolute 14 mass. We have compared it with carbon 12 isotope, and then we know that according to that, if we say carbon 12 isotope is 12 AMU, in that case we can say nitrogen is 14 AMU, oxygen is 16 AMU. That is relative atomic mass. Okay, now bacha, for example, we are talking about gram atomic mass. We have done that. That is nothing but when we calculate for 1 mole. When we calculate for 1 mole, okay. For example, 4 gram of Ag. For example, 4 gram, that is 4 moles of Ag atom. This is the gram atomic mass. That means 4 moles is 4 into this much. Okay. The atoms here will be 2 point this. Okay. This is your mole concept here. Average atomic mass, bacha. Now, for example, I am talking about any isotopes here. I am talking about chlorine. Chlorine has 2 isotopes. Carbon has so many isotopes. Oxygen has so many isotopes. If we want to calculate the average mass, right, how do we calculate it? That will be average atomic mass according to the isotopes will be atomic mass of isotope into abundance, okay, divided by 100. For example, I have an isotope that is having M1 mass and the abundance here is A1, right? And second isotope has abundance A2 and third mass has abundance A3. Now, in this case, the percentage abundance, the average atomic mass will be, that will be equals to M1 into abundance plus M2 into its abundance plus M3 into its abundance divided by 100, right? Okay. How many isotopes you have multiplied by the abundance divided by 100 will be the average atomic mass, right? Okay. Next term that we have, next term is the molecule. Now what is a molecule? The smallest particle, the smallest combined particle that is taking part in the chemical reaction. Okay, that is called a molecule. Okay, it is combined, it is chemically bonded with some other atoms, right? But still it is the tiniest particles, because if you are fusing the chemical bonds here, you will have the smallest molecule there. Okay, so a group of atoms bonded together chemically representing the smallest fundamental unit of chemical compound that can take part in the chemical reaction. For example, H2O, CuCO3, all these are molecules, right? Okay, molecular mass is like we calculate the mass, atomic mass. For example, we are calculating the molecular mass for CaCO3. Okay, for CaCO3, that will be equals to mass of Ca plus mass of carbon plus 3 into mass of oxygen. Okay, that will be 40 plus 12 plus 3 into 16. That comes out to be 100. So now, if I am talking about one molecule of CaCO3 or CH3O3 will have mass 100U, and 1 mole, that means Na particles, that means 6.022 into 10 raised to power 23 particles will have of CaCO3 will have 100 gram. Okay, that will be 100 gram of molecular mass. Okay, right? Okay, yes, 100 is the right thing. Yes, bacha. Yes, I'll be doing questions here. I'll be doing questions related to that. Okay, right. So next is molecular mass. You know how to calculate. Just multiply by the number of atoms that it has into the atomic mass of that particle, that atom, right? Next we have gram molecular mass. For gram molecular mass, again same thing. That is 1 mole. The mass of 1 mole of molecule. 1 mole of molecule. That is called gram molecular mass. Now, same way, this was the gram molecular mass. This was the gram molecular mass. This was the molecular atomic mass unit. This is an atomic mass unit, or you can say molecular mass unit. Right? This is gram molecular mass. molecular mass, or you can say this is the molecular mass, or you can say this is the molar mass. Same thing, right? Next we have formula mass. Formula mass is for those compounds that do not exist individually. Like I can say Ka is bonded to Cl here. I have one different molecule here. Like NaCl is not a different molecule here. It's not like Na is bonded to Cl and then another molecule is bonded to another molecule and then we have a cluster there. No, right? It exists as a lattice structure. Like we have, like I'm talking about this thing here. Okay, talking about this thing here. For example, this is the structure here. So how will be the structure be? For example, I have one Na atom here. I have one Cl atom here. I have one Na atom here. One Cl atom here. These are called the lattices. That was in your syllabus in solid states, but now they are not in your syllabus. So these are the lattices. Okay, these are the unit cell. Okay, here we have the atoms are not bonded to just one. Okay, there is one formula unit. For example, I say in this whole, if I say it has 37 Na positive and it has 37 Cl negative. That way I can say I have for every one Na positive, I have one Cl negative. That means the formula will be NaCl, right? That is for ionic lattices. This is for ionic lattices. They are not directly bonded to each other. They exist as a lattice structure. So how do you calculate? The calculation is same way. For example, we see the formula unit here. The formula unit for NaCl is NaCl. Okay. For KNO3, this is the formula unit. Okay. This is the formula unit for ZNS. This is the formula unit for CF. That means for every calcium atom, you have 2 fluorine atoms, right? This is the formula unit here. And how do you calculate the answer for this? How you to calculate the mass for this? Similar way, okay? Okay, that will be atomic masses of Ca plus 2 into atomic masses of fluorine. It will be atomic mass of potassium plus atomic mass of nitrogen plus 3 into atomic mass of oxygen. How to calculate that will be completely similar, okay? Yes, okay? Yes, bacha, I'm already very slow. I'm already very slow right now, है ना? Okay. Next is uncertainty in measurement. Now, how do you know uncertainty? For example, we are doing experiments in the lab, right? There will be uncertainty. So there are 2 factors mainly that are. First is wait. So this is the true value. For example, this is the true value, and this is the measured value. So true values that is expected in the lab, but measured values that is calculated by you. So always there is uncertainty in the laboratories, right? That uncertainty, that is why we measure here the error. Okay, they're talking about the error here. So we have 2 things here. One is precision. Wait. I think that is not written here. But don't worry. Okay. So what is meaningful way to handle? Okay. No, it is not written here. So one thing is precision, one thing is accuracy. Precision means when we calculate so many, for example, you need to calculate the value of x should be the true value is x. Okay. But you have calculated with first experiment that was x1, with second experiment that was x2. Third experiment you have x3. So now the value that is closer to this x, okay, for example x2 is very closer to x, so I will say x2 is precision value here, okay, it is closer to this. Now when we talk about accuracy here, accuracy is, for example, I am talking about which is the most accurate value. This is the true value, this is the accurate value. If I get a value that is exactly similar to x, okay, exactly same to x. For example, this is 7, and if I get a value that is 7, that will be accuracy. If I get a value that is 6.9, 6.8, that will be precision. Okay, that is the difference here. So now let us talk about the scientific notations here. Okay, scientific notation is nothing but, for example, we have Avogadro's number that is 6200000000. So because of atoms are very small, the particles are very large. So we need to have a scientific notation for that. That is nothing but, Comparing then to, if I am calculating the mass, that will mean 10 raised to power minus something, because the mass is very small. If I am talking about particles, that will be 10 raised to power plus, that because the particles are very large. Okay, this is what they are talking about, that if you have number is greater than 1, that will be exponent must be positive. That is for particles. That is for particles, because we have large number of particles when we are talking about atoms and molecules. And when we are talking about masses, okay, when we are talking about mass here, okay, mass is very small, that is why exponent will be negative here, right? Okay, next thing bacha that we have is addition and subtraction. So here addition and subtraction will be done. For example, we are adding this simple addition and subtraction, okay? So for example, this is the exponent, this is the exponent. You know how to add this or extract this. You're going to take common out of it and then add or subtract it, okay? Now, very basic thing. These are the basic things here, okay? Multiplication, how it is done? Simple. In the mathematics way that you do, similar that way you are going to do it. Next is significant figures. So now they can ask you questions on the significant figures. Okay, again a very simple thing. What is significant figure, everyone? Now, what are the rules here? Very 3-4 simple rules for significant figure. First is all non-zero digits are significant. For example, here we have 1, 2, 3, 4. Here we have 4 significant figures. And we are talking about this one. Here, 0 preceding, that means zeros that are after, right? Preceding to first non-zero. For example, this is the non-zero. This is the first non-zero digit here. 3 is the first non-zero digit here, right? In this case, all the zeros present, preceding, that means before the non-zero, is non-significant, right? So the significant values here will be 2, right? These will be it has 2 significant figures. Right? Now, if you have zeros in between 2 non-zeros, okay? For example, this is 8, this is 5, right? All these zeros will be significant figures, that it will have 1, 2, 3, 4, 5, 6, 7. It will have 7 significant figures, right? Now, zeros after the non-zeros will be significant. For example, if we are talking about this, the zeros preceding the non-zero is not significant, but the zeros after the non-zero is significant. So it will have 3 significant figures. Yes? Okay? Yes. Very good. They are very simple. Now this is addition and subtraction. Now they are saying in case of addition, subtraction, multiplication, division, what we take that the result should be reported at same number of decimal places as number carrying minimum numbers of decimal places here. For example, I am talking about 11.1, 1.1 in this. So after this, the result will be 12.32, right? Okay. So what will be the final answer here? The final answer will be minimum decimal unit. You have this one. Okay, this one is having minimum decimal unit. So in that case, we will have 12.3 only, right? Okay. This is also not asked in your this. Now we have laws of chemical combination from where questions are asked in your exams. Right? Okay. For laws of chemical combination, we have 5 laws. Right? We have 5 laws. First, we have law of conservation of mass. For law of conservation of mass, we used to do it in earlier classes also, that if we have, for example, I am talking about a reaction where this R1 plus R2 are the reactants, and we have P1 plus P2. Okay. So in this case, I have mass. For example, this is 8 grams. This is 7 grams. Okay, this is also 8 grams. So this will be 9 grams, or this is 7 grams. Right? Okay. So the mass of reactants will be equals to mass of product. That means mass is not created or destroyed. It is just converted into one form to another form. That is law of conservation of mass, on which Dalton's atomic theory is based upon. Right? Okay. So this is law of conservation of mass. He reached conclusion that matter can neither be created nor be destroyed. This is called conservation of mass here. Second law that we have is law of definite proportion. For law of definite proportion, what we have, for example, definite proportion is okay. Let us talk about this thing. Okay. For definite proportion, I am saying we have H2, right? Now H2 will always have 2 2 hydrogens and 1 oxygen. Whether it is taken from a pond, whether it is taken from some ocean or from your home or RO, anything, the formula of water is not going to change, right? The formula of water will always be H2O. That the ratio here will be the atomic mass ratio. This is 2 hydrogen plus 1 oxygen, 2 ratio, this is 16, that is 1 ratio 8. This is always going to be the ratio, right? This is the atomic mass, this is the ratio of atomic masses, right? And about the atoms here, the atoms ratio is always going to be 2 ratio 1. That is ratio of hydrogen ratio oxygen is always going to be 2 ratio 1, and the atomic ratio will always be going to be 1 ratio 8. Any compound on this earth, right, will always have same constituent. That is the definite, that it will have a fixed proportion of atoms, fixed proportion of masses of atoms, right? Okay, that is definite proportion. Next we have bacha some exceptions here. Like for example, this is called reverse is not true here. Why reverse is not true? For example, I am talking about CH2O, I am talking about C6H12O6. The ratio in both the cases, the ratio of carbon, hydrogen and oxygen is 1 ratio 2 ratio 1. Here also it is 6 ratio 12 ratio 6, that will be 1 ratio 2 ratio 1. So we can say that all the compounds will have same ratio of the atoms, but all the compounds that have same ratio of the atoms, for example, I am talking about CCHO, that is aldehyde, that is methanol, okay, that is methanol, this is called methanol, okay, this is methanol. But if we talk about C6H12O6, that is glucose. So now the formula here is different, but the ratio of masses is same, okay. So the reverse here is not true, okay. This is aldehyde, and this is glucose, and this is glucose. Yes. Next we have for isotopes, okay. Next we have for, okay. So now bacha, next we have for isotopes, okay. Now we have for isotopes. For isotopes, they're not valid. For example, I am talking about H2O and I am talking about D2O, okay. I am talking about these two things. So here, if we talk about the ratio, here the ratio of atomic masses will be 2 ratio 60. And this will be because deuterium has double the mass of hydrogen. Here it will be 4 ratio 60. So here the ratio is not same. So this is not applied for isotopes, right? Okay, this is heavy water and this is normal water. So it is not applied here. The atoms should be same. Okay, the isotopic nature should be same here, right? Next thing that we have is law of multiple proportions. For law of multiple proportions, everyone see this here. For law of multiple proportions, if I talk about H and O, okay, if I am talking about hydrogen and oxygen, so I can say hydrogen and oxygen can combine in various ways, right? It can be various compounds here. If I talk about two main compounds of hydrogen and oxygen, that first compound is H2O, right? First compound is H2O. Second compound here is H2O2, right? We have two compounds here, right? Okay, so now what we are going to do here, we have H2 and we have H2O2, right? For H2O, that will be the ratio here will be the ratio of hydrogen and oxygen is going to be 2 ratio 60, right? Okay, and here the ratio of hydrogen and oxygen is going to be 2 ratio 32, that is 1 ratio 60, right? Okay, yes. Now if I fix this, so now what do you mean by law of multiple proportion? That states that if we have two atoms that combines in different ratios, so now here it is combining in different ratio, here in different ratio, it is combining in different ratios and forming different compounds, and the ratio of those compounds, if I fix hydrogen is fixed here, if I fix 1, okay, if I fix the mass of one atom here, I am fixing the mass of hydrogen here, okay, this is 2 and this is 2. In that case, it is saying the ratio of, this is for example, I am saying this is the first compound, this is the second compound. Okay, the ratio of oxygen number 1 and the ratio of oxygen number 2 equals to 16:32. That is a simple whole number ratio. Okay, that is a simple whole number ratio. Whole number ratio. This is law of multiple proportion, that we have two atoms combining to form two different molecules. The atomic ratio, we have two different atomic ratio of atoms there. If we fix one atom here, the ratio of the other atom, right, that will be, here we have 16, here we have 32. The ratio of 16:32 is a simple whole number ratio. Okay, that is one ratio. Yes, okay, perfect. I have also taken that example here, right? Another example we have for carbon dioxide and carbon monoxide. So carbon and oxygen can combine together to form carbon dioxide and carbon monoxide. For carbon dioxide, we have, this is 12, this is 16:2, that is 32, right? If we fix one thing here, if we fix the mass of carbon here, I am fixing the mass of carbon here, okay? I am fixing the mass of carbon here. We are left with oxygen here. So here, the ratio of oxygen, this is the first compound, this is the second compound, right? The ratio of oxygen from one and the ratio of oxygen for second is going to be 32:16. That is 2:1. Again, this is a simple whole number ratio. Yes, this is again a simple whole number ratio. Next example here is for nitrogen and oxygen. We have so many nitrogen oxides, right? We have so many nitrogen compounds. Nitrogen and oxygen together can combine to form different compounds here. For example, NO, N2O, NO2, N2O3, NO5, N2O5, NO3. All these compounds are between nitrogen and oxygen, right? So now let us see, are they also in simple whole number ratio? Okay, so the ratio of nitrogen and oxygen, here the mass of nitrogen is 14, right? The mass of oxygen is always 16. This is the mass of nitrogen and oxygen. We have one nitrogen, 14:16. This is 14 into 2 ratio 16, that is 28:16. Nitrogen is 14, oxygen 2, that means 16 into 2. Nitrogen is 2, that is 28 in, ratio 48. This is 14:48. This is 2 into 14 ratio 5 into 16, right? We have different ratios here. Now, here I am going to fix the ratio of the masses of nitrogen. Why not oxygen? Because that is going to be complicated for me. Okay, nitrogen in all the cases, this is 1, this is 2, again 1, 2, 1, 2. So I can multiply this by 2, we can multiply this by 2, we can multiply this by 2. And we will always have 2 nitrogen in all the cases, right? So here, after multiplying those compounds which have 1 nitrogen by 2, I am fixing the value of nitrogen. I am fixing the number of atoms of nitrogen here, that is 2. Okay, I am fixing the nitrogen here, fixing nitrogen here 28, 28, 28, 28, 28, 28. That is always will have 2 nitrogen. The oxygen comes out to be 32, 16, 64, 48, 96, 80. So can you see this? This is nothing but the multiple of, this is nothing but the multiple of 16. Multiple of 16. That means this is in simple whole number ratio, right? This is in simple whole number ratio. This is in simple whole number ratio, right? Okay, this is in simple whole number ratio, right? Again, this law is again verified. Understood, bacha? Any problem till now? Sure. Wait, you want to know the names of scientists that propose different laws here, right? Okay, so this was given by, this is all from your NCERT. This was given by Lavoisier, right, in 1789. But nobody asked you this, okay? Nobody is going to ask you the history behind that, okay? So now this is given by Proust. This law was law of definite proportion was given by Proust. Next we have law of multiple proportion that was proposed by Daltons, right? That was proposed by Daltons. Yes, okay? Next, bacha, we have law of reciprocal proportion. So now what is reciprocal proportion? Let us see that with the help of an example. Okay, we are going to do this with the help of an example. For example, I have carbon and sulfur here, and they are combining to form carbon sulfide. Okay, carbon and sulfur are combined to form carbon sulfide. Okay, now I have a third atom. Okay, now the carbon and oxygen are combining and the sulfur and oxygen are combining. That means what I have done, two atoms, they combine together to form one compound, that is carbon disulfide. Now this carbon disulfide is made up of carbon and sulfur. This carbon is going to react with the third atom. This sulfur is going to act with the third atom, and it is going to form carbon dioxide, and here it is going to form sulfur dioxide. Okay, these are the two compounds that it forms. So now what is law of reciprocal proportion? Let us see. Okay, it is saying two atoms, when they combine together, that means CS2, the atomic mass ratio, everyone here, the atomic mass ratio here will be, everyone here, what is the atomic mass ratio? That is, this is 12 ratio 32 into this 64, right? This is the atomic mass ratio, that is 12 ratio 64, because the mass of sulfur is 32 into 2, that is 64. The atomic mass ratio here is 12 ratio, this is 32, right? And here it is 32 ratio 64, right? Okay, so now what they are saying, fix the mass of third element, the third element that I took here, the third element, that means oxygen. Okay, I am going to fix the mass of third element that is reacting with both carbon and sulfur, right? Here oxygen is reacting with carbon, here oxygen is reacting with sulfur, that is the third element. I am going to fix the mass of oxygen here, right? Okay, yes. I have written it wrong here. This should be 32 ratio 32. Okay, this will be 32 ratio 32. Okay, fixing this, what we will have, this is carbon, the ratio of carbon and sulfur. After fixing the mass of oxygen, that is 32 and 32. Okay, this is 32, this is also 32. Right? We will have the carbon and sulfur ratio will be, this is 12 ratio 32. Right? This is 12 ratio 32. Right? This is the ratio of carbon and sulfur. Right? See this very carefully, what we did here. Carbon and sulfur, when they directly combine together, they are in the ratio 12 ratio 64. Right? This is the carbon ratio sulfur. But now when they combine with third element, after fixing the mass of third element, the ratio is 12 ratio 32. Right? Okay. So I'm writing it here original, and this is the given. Right? This is the original thing. So what it is saying, that here, this is carbon, this is 12 ratio 64. This is original, that is carbon ratio sulfur is 12 ratio 64. This is original, and for the other part, this is original, right? And carbon ratio sulfur with third element, I am writing it here O2. That is, with O2, it is 12 ratio 32. That is 12 ratio 32. Right? So here also, fix any carbon, fix mass of any element here. Here I am fixing the mass of carbon here. What I am going to have? I am going to fixing the mass of carbon. I am going to have ratio of sulfur is going to be, this is for example sulfur original, right? Ratio sulfur with oxygen, that is going to be 64 ratio 32, that is 2 ratio 1. Now this ratio is the simple whole number ratio, that is law of reciprocal proportion, that is not given in your NCERT, right? Okay, Now let us go through the statement here. Okay, I'm again repeated it. Okay. Yes, bacha, I'll do that. Okay, I'll do that. Right? Yes. Now this is law of reciprocal proportion. That is, if two elements combine separately, we have two elements like we have taken the example of carbon and sulfur here. Okay, I have taken the example of carbon and sulfur. So if two elements combine separately with same weight of third element, that is, I have taken the same weight of oxygen here. Oxygen was fixed, right? The ratio of masses in which they do so are either the same or simple multiple of masses in which they combine. This means what they are saying. This means they are saying the masses in which they are doing so directly, that is 12:64, or this mass. Okay, these two masses are in simple whole number ratio with each other, right? 12:64 and 12:32 are in simple whole number with each other. How we define that? We fix the mass of carbon here and we have 16, that is 2:1. That means if they are combining, if carbon and sulfur are combining together, or it is combining with the fixed mass of third element, the ratio of carbon and sulfur is going to be in the simple whole number ratio with the original one and with the when it combines with the third element here. Yes, bacha, is this clear to you? Because this was a little tricky, right? That was little, a lot of here and there, right? A lot of confusion in this particular law. Is this clear to everyone here? What is law of reciprocal proportion again? We have carbon and sulfur, they are combining in the ratio 12:64. If they are combining with a fixed mass of third element, then we say carbon and sulfur ratio here and the carbon or sulfur ratio when they are combining directly, they both are in simple whole number ratio, right? Okay, yes. Next law, bacha, that we have here is, okay, we have already done this, right? Next, bacha, we have Gay-Lussac's law. For Gay-Lussac's law, very simple law, okay, very simple law. For example, it is saying when gases combine are produced in a chemical reaction, okay. For example, we are saying this, okay, gases are combining to form another compound here. So when they do so, they are saying they do so in a simple whole number ratio. That means the ratio of hydrogen and oxygen and water is going to be a simple whole number ratio, that is 1:2:1. That is a simple whole number ratio, right? Same applying to the another thing, that is Haber's process here. Here gases are combined together to form the product here, right? It is doing so in 1:3:2. Okay, they are combining in the simple whole number ratio. Ratio by volume of nitrogen, hydrogen, ammonia 1:3:2 is a simple whole number ratio. Next we have Avogadro's law. Again a very simple law. Avogadro law states that, for example, we have two beakers here. For example, we have two beakers here, right? We have two beakers here. Here we have gas, that is H2, and here I have chlorine gas. Okay, here I have chlorine gas. Here I have hydrogen gas, here I have chlorine gas. Now, if I am saying I have two gases in different containers, right? The volume are same here, right? This is also V milliliter, this is also V milliliter. If the volumes are same, that means the number of moles is going to be same. So if it is having N1, so this is also going to have N1, okay? If it is having X moles here, if it is having X moles here, this is also going to have X moles, right? Okay, if the volumes are same, the number of moles is going to be same, even for different gases here. Okay, if the gases are different but the volume is same, number of moles is going to be same here, right? Okay, or we can say, if I say the volume here is V and this is 2V and this is 2V milliliter, right? So what is the value of y? If it is having x moles, what is the value of y? Right? If the volume is doubled, here it is having V volume and here it is having 2 into V volume. Volume is doubled. In that way, we will say the X is going to be doubled here. Right? The moles is going to be double. If the volume is doubled, moles will be double. Volume is tripled, moles will be tripled. Okay? So for different gases also. So Y is going to be 2 into X here. Right? That is Avogadro's law. Okay, bacha? Yes? Perfect. Next we have mole concept. For mole concept, a very simple thing, okay? Very simple mole concept. Nothing to worry about. Nothing to worry about. Just 2-3 formulas here, right? And mole concept will be sorted, right? And mole concept will be sorted. So now, bacha, see. If we talk about moles, moles is represented in 3 formulas, okay? It has 3 formulas, right? It has 3 formulas. One is in mass, other is in particles, third is in volume, right? Okay? And here we write it, here always we write, here we will write molar mass. This will be the molar mass, mass of 1 mole. This is a mass, if we are converting moles in mass, here we are going to write mass of 1 mole. Here we are going to write particles of 1 mole. That is Avogadro's number, okay? That is Avogadro's number. And when we are converting moles in volume, we are going to write volume in 1 mole. The molar volume, the volume of 1 mole of gas. Okay, that is molar volume. That is molar volume, right? Okay. And here we are going to write given mass, given particles, that may be in atoms or molecules. And here we are going to write given volume. Okay, this is given volume, right? Now, next thing that we have converted 3 formulas here, right? One is in mass, second is in particles, third is in moles, right? This is for always. For example, I am talking about H2. The molar volume is 2. For nitrogen, the molar volume is different. For every different atom, molar volume is going to be different here, right? Number of particles for 1 mole are going to be same. That is given particles. Okay, I am representing it by N. Okay, let's not represent it by N here. Okay, represented by capital N, and this is 6.022 into 10 raised to power 23. I represent given mass by small m and molar mass by capital M, right? And to represent volume here, this is the given volume. And what is the molar volume? That is 22.4. Okay, that is 22.4 liters is the given volume. Okay, for one is the molar volume, that is fixed. Okay, that is at standard temperature and pressure. 22.4 liter when we are given 1 atmospheric. 22.7 if we are given 1 bar pressure. Okay, if we are given nothing, we will write 22.4 only. Right, these are the 3 formulas here. Now, how to calculate masses of first 20 elements here? Okay, how to calculate? Usually they will ask first 20 elements only, right? So always, if we have atomic number, always we have 2 things here. Okay, either atomic number is going to be even or atomic number is going to be odd, right? Either atomic number is going to be even or atomic number is going to be odd. Or atomic number is going to be odd, right? 2 things only. If atomic number is even, right? In that case, atomic mass equals to 2 into atomic number. 2 into atomic number, right? Okay, if that is even. Now, if the atomic number is odd, in that case, atomic mass is going to be 2 into atomic number, right? plus 1. Right? Okay. For example, I am talking about oxygen. Oxygen is having 8. Okay. The atomic number is 8. Right? For oxygen, the atomic number is 8. So the mass will be 8 into 2, that is 16. Right? But the exception here is everyone. The exception here is Hey bunny argon. Hey bunny argon. That means hydrogen, beryllium, nitrogen, argon. So these are the exceptions here. Which has odd atomic number, but the atomic masses are double. Right? For example, if we talk about nitrogen here, nitrogen is having 7 atomic number, right? But here the atomic mass is not 2 into atomic number plus 1. The atomic mass is 2 into atomic number. So these are the exceptions here, okay? These are the exceptions. Yes, bacha? Okay, this is how you're going to calculate molar mass, right? Okay, for any particle, any atom, any compound that is given to you. Okay, so this is nothing but another way of representing mole concept, right? Already done that. Next we have percentage composition. For percentage composition, for example, they are asking you the percentage. Okay, always remember one thing. If you want to calculate the percentage of H2, percentage of hydrogen in H2, that will be mass of 2 hydrogen divided by mass of H2 into 100. Okay, mass of that element in the formula, right? For example, if I am talking about percentage of CO2, in that case it will be mass of percentage of carbon in CO2. Carbon in CO2 will be, now in carbon dioxide you have 1 atom of carbon. So here you will write mass of 1 carbon divided by mass of CO2 into 100. Right? Okay, bacha? Understood? Here always you will write molar mass of that element in the compound. Okay, the number of atoms will be multiplied here. Right? For example, I am asking you to calculate percentage of oxygen in CaCO3. Okay, in that case what you are going to write here, that is going to be the mass of oxygen in this, that is 3 into oxygen mass divided by CaCO3 mass into 100. That is going to be 3 into mass of oxygen is 16, right? Divided by CaCO3, that is 100 into 100. Right? That is going to be the right answer. That is mass of oxygen in CaCO3. Mass of carbon will be everyone. What will be the mass of carbon here? Mass of carbon will be percentage of carbon in CaCO3. That is going to be this is 12 divided by 100 into 100. Right? We have mass of 1 carbon atom. Here we have mass of 3 oxygen atoms. Right? Okay? Yes? Very good. Next is the molecular formula and empirical formula questions. Right? So how to calculate the molecular formula and empirical formula? See, empirical formula is the simple whole number ratio. For example, for C6H12O6, this is the molecular formula of glucose, right? But to calculate the empirical formula, this will be the simplest whole number ratio. So the empirical formula is going to be 6 divide this by 6, that will be C1H2O1. This is the empirical formula. That is the simplest whole number ratio, right? That is the simplest whole number ratio of the atoms. So now they will ask you questions To calculate the molecular formula, to empirical formula, they will give you vapor density or anything like that, okay? Right? So these questions will be asked in the exam. So see how to calculate this. Let us see this, okay? So here are few formulas. Before doing that, few formulas that we have. First is vapor density. First is vapor density, right? First is vapor density. So now vapor density is equals to density of gas divided by density of H2. Now that is equals to bacha, vapor density is equals to density of gas by density of H2. That is equals to, applying the ideal gas equation here, PV is equals to NERT, you will have mass of gas divided by mass of H2. So now what is the molar mass of H2? Molar mass of H2 is 2 here, right? And this is the mass of gas here. So this is the relation, vapor density. This is the relation here. So now what they can give you, they will not give you, maybe they will not give you the molar mass of that compound directly. They will give you the vapor density, right? They will give you the vapor density. So how to calculate molar mass? Vapor density multiplied by 2 is equals to molar mass, right? This is the first formula. Second formula is, if we talk about the empirical mass and empirical formula. Molecular formula, and I'll simply write it, molecular formula is equals to empirical formula into N. For example, in case of glucose you have C6H12O6. This is the molecular formula. CH2O, this is the empirical formula. So now if you multiply empirical formula by 2, that will be molecular formula, right? That will be molecular formula. This means that always we have molecular formula is equals to empirical formula into N, and where N is that factor which we multiply and we get molecular formula, right? This is the first formula. Second formula is, if we calculate the molecular mass here, molecular mass is equals to this N multiplied by empirical mass, This is the second formula. If you know these two formulas, you will be able to calculate empirical formula here, right? Okay, so how the questions will be given? Let us try to solve this answer, okay? Okay. Let us try to solve the question here, okay? A compound contains 4 points. See, here you just need to draw this table here. Just draw this table here, okay? Just draw this table here. First, we will write the element here. First case, we will write the element here. Second will be, we'll write the atomic mass that is given to us. Third, we will write the molecular mass, right? Fourth, we will write the number of molecules. Fourth will be the number of molecules, right? Fourth will be the number of molecules, right? And then we will have the simple whole number ratio, right? See, this is the element here. This is the element. This is the atomic mass. And how you will write the atomic mass? Ma'am, here we are given the percentage. No mass is given to us, right? Or I'll write it here, given mass. Okay, given mass you will write. Or you will say percentage you will write here. Okay, you will write the percentage here. Here you will write the molar mass. Here you will write the molar mass. Or I'll write it here, atomic mass. Yes. Here you will calculate the number of moles. Number of moles is equals to given mass by atomic mass. Okay, given mass, that is, so simply you can write it here. This will be given mass. This will be simply, you can write it here. Given mass divided by atomic mass. And this is the simple whole ratio. This is the simple whole number ratio. Right? Okay. just add the things here and write it down, right? Okay. No, this is not time consuming. Very simple, very simple. See, simply write it here, hydrogen. This is carbon. This is chlorine. Okay. So what are the atomic masses here? For hydrogen, that is 1. Carbon, you have 12. And for chlorine, you have 35.5. Okay. These are the masses. These are the atomic masses. And what is given to you? This is in percentage. Just convert it into grams. That is 4.07 grams here. Right, this is 24.427 and this is 71.65. Okay, you are writing the mass here that is given to you, and this is the atomic mass here. Right, you have simply written it. Now, next thing that we are going to do here, given mass divided by atomic mass. So now this will be divided by this. You will get 4. Here you will get 4.07. Here you will get, wait, here you will get 4.07. Here you will get 12 into 2. This is something 2. Okay, you can write it here, 24.27 divided by 12 here. That is approximately equals to 2. This is approximately equals to 4. This is approximately equals to 2 here, right? This is also approximately equals to 2 here, 35.5. 35 into 2 is somewhat equals to 70, right? Okay, so this is approximately equals to 2. So in calculating this in simple whole ratio, you will write it here. This is 2, 1, 1. This is the simple whole number ratio here, right? That is the simple. Hello, bacha. So this is the simple whole number ratio. You can say this is hydrogen, carbon and chlorine. This is 211. So this is 211. So you have the empirical formula. So this is the empirical formula, right? This is the empirical formula that you have CH2Cl. This is the empirical formula, right? What is the empirical mass here? Everyone, what is the empirical mass here? That is 14 plus 35.5, that is 5. 949.5, that is the empirical mass, right? 49.5 is the empirical mass. So what else are you given? A compound. What is the empirical and molecular formula? Molar mass, they have given you molar mass. Molar mass is equals to 98.9, okay? 98.96 grams. So you have empirical mass here, right? Divide these two things, molecular mass divided by empirical mass. Molecular mass divided by empirical mass, that is equals to 98.96 divided by 49.5. This is approximately double of this, right? So that is approximately equals to 2. That is approximately equals to 2 here. Okay, this is the value of N. This is the value of N. So empirical mass, so molecular formula equals to empirical formula. And here you have N, right? Okay, empirical formula is CH2Cl by 2. This is 2. This is C2H4Cl2. This is your molecular formula, right? This is your molecular formula. Okay? Yes. Simple. Okay, we have just written it. Okay, firstly write the atom here, then given mass here, then atomic mass here. Divide these two things, you will get the percentage here. Okay, you will get the moles here, right? You have get the moles. Then just simplify this in simple whole number ratio, right? So I divided this whole by 2. Okay, I divided this whole by 2. I'll get 2:1:1. This is the empirical formula, right? We have molecular formula. Divide molecular by empirical, you will have the value of N. That is the factor that you should multiply, right? After to calculate the molecular mass here, this is to calculate the molecular formula, right? That is empirical formula N, and this is C2H4Cl2, right? Okay, simple. Yes, super easy now. Yes, very easy. Next we have. Wait. Next is the balancing the chemical reaction is very easy. This is a simply by hit and trial method. Yes, you have also done this in lower classes, right? Firstly, balance the hydrogen atom, then oxygen atoms, all these things, right? Okay. Now, let us do some questions. Let us do some questions here. Okay, let us do some questions here. So there are two things. One is limiting reagent and the other is stoichiometry, right? So the difference in the stoichiometry and limiting reagent is that in stoichiometry, you're given two reactants, okay? The mass will be, the whole thing will be consumed, right? In that case, you will not have something that is in excess and something that is in deficiency, right? But in limiting reagent, you will be able to see that something is left behind. That means that is the question of limiting reagent. So for stoichiometry, let us see how to solve the questions of stoichiometry. Stoichiometry, the questions are very simple, okay? Very simple method. Always convert everything. Convert into moles. You have to. Whatever mass is given to you, convert that mass into moles. Then you will be able to calculate the mass, the particles, the volume, right? Ma'am, what do you mean by that? Now we will convert something into moles and we will be able to calculate everything. Let us see this with the help of an example, okay? Now you have find the mass of, let us see this with the help of example because these questions are not theoretical questions, right? You need to, to understand this, you need to have some example only, then you'll be able to understand what I'm trying to say, right? So firstly you have find the mass of O2 required when 5.8 gram of butane is burnt, right? You have butane, that is C4H10, right, is burnt here. This is the combustion reaction. For always combustion reaction, you have CO2 and you have H2O. The first step in stoichiometric coefficients, in stoichiometric questions, are that you have to balance the equation. The first step is to balance the equation. If you are not balancing the equation, the answer will be wrong. Definitely the answer is going to be wrong, right? Okay, so firstly balance the equation here. So to balance the equation, what I'll do, I'll multiply everyone here. Yes. So this is, let us balance the equation, right? Let us balance this. Yes, everyone. Firstly, what I am going to do here, let us balance the carbon atoms here. Okay, let us balance the carbon atoms here. So this is having 4 carbon atoms. This will be 4 carbon atoms. Now let us balance the hydrogen atom. These are 10 hydrogen atoms. This is simply by hit and trial method. Okay, this is 10 hydrogen atoms. So now let us balance the oxygen atom here. It is having 2 oxygen atom and here we have 4 into 8 oxygen atom plus 5. Okay. To balance it out, we should always have even number will be considered, right? Okay, let's convert the oxygen atom into even number, right? To convert oxygen atom into even number, I should multiply this oxygen, this number should be even, right? So, what we can do it here, let us multiply this by 10 and let us multiply, if I am multiplying this by 10, I will have 4 carbons, right? And this is 10, in that case I will have 20 H2O, 20 hydrogens here. So I should multiply this by 2 also, right? If I am multiplying this by 2, this is going to have 8 carbons here, this is going to have 4 carbons here. So let us multiply this by 8 also. So simply hit and trial, right? Okay. Now let us see, the carbon atom here is 4 to 8, right? And here also it is 8. Right? The hydrogen atom here is 20 and here also it is 20, right? The oxygen atoms here. Yes, very good. The oxygen atoms here are 2 and here we have 16 plus 10, that is 36. That is 36. So now if I multiply this by, okay, if I multiply this by 13, right? No. Just a minute. Have I balanced it right? Have I balanced it right, everyone? Yes? This is 8 to 16 plus 10. Oh, this is 26, right? Okay. Yes. Okay. Yes. Yes, bacha? Yes, bacha? So now you have this carbon, oxygen and hydrogen are balanced here. So now after balancing this, what we are going to do here, after balancing the chemical reaction here, after this, firstly what they are asking you, first step is to balance this. Second step, find the mass of O2 required when 5.8 gram of butane is burned. They are asking you the mass of O2, okay? The mass of O2 they are asking you, right? The mass of O2 required when 5.8 gram of butane is burned. When this much of butane is burned, okay? So now, firstly convert everything that you are given in moles, okay? This is 5.8 grams of butane. Now convert this into moles. Convert this into moles. This is nothing but 4 into 12 plus 10. That is 58, okay? That is 58 gram per mole. This is a molar mass. So the moles here will be, that is 58 by 5.8, that is 0.1 mole, right? That is 0.1 mole. So after this, I am going to apply the stoichiometry here. I am going to apply the stoichiometry here. That is, this is given to be 0.1 moles. What I am going to do here, I will write for 2 moles, for 2 moles, for 2 moles, I have 13 oxygen, right? 13 oxygen, 13 moles of oxygen is consumed, right? 13 moles of oxygen is consumed, right? For given reaction, for the balanced chemical equation, we have 2 moles of butane consumes, 2 moles of butane consume 13 moles of oxygen, right? That means for 1 mole, it will have 13 by 2 moles of oxygen. That means for 0.1 mole, for 0.1 mole, that is going to have 13 by 2 into 0.1 mole of oxygen, right? Now you have the moles of oxygen. Moles of oxygen is 6.5 into 0.1, right? Moles, right? You have the moles of oxygen here. Now you can calculate the mass of oxygen, you can calculate the particles of oxygen, you can calculate the volume of oxygen, right? The mass of oxygen is going to be, for example, this comes out to be how much? 0.65, right? Okay. Yes, 0.65 moles. Is it? This is 0.65. 13 by 2 into this, right? So you can calculate here, for example, this is 0.65 into mass of oxygen is 32. For calculating the particles, that is Avogadro's number into 0.65. For calculating the volume, that will be 22.4 into 0.65 volume, that is in liters. So you can calculate anything, okay? The best method is to convert it into, firstly balance the equation, After that, given the one thing will be given and one thing will be asked to you, okay? Compare those two things here, okay? Compare the moles of those two things here, okay? Then you will, in terms of, this is given to you, these two are given to you, this is given to you and this is asked to you, okay? So you will calculate the number of moles of asked quantity, right? After calculating the number of moles, you can calculate mass, particles, volume, anything from there, okay? You can calculate anything. Yes? Now, next we have another question, that is That is, find the mass of CaCO2 that must be decomposed to produce sufficient amount of CO2. First is just write down the chemical equations here. Okay, the mass of CaCO3 that must be decomposed. Okay, we need to decompose the CaCO3, that is quicklime and carbon dioxide. Okay, it is balanced. Yes. Find the mass of CaCO2 that must be decomposed to produce the sufficient amount of CO2 to convert Na to CO3. We have Na2CO3, right? Now, the mass, the carbon dioxide that we have from the decomposition of calcium carbonate, we are going to use this carbon dioxide, right, and water here to convert it into sodium bicarbonate. Right? Okay. Now, next thing here is, ma'am, what is given to us? We have to calculate the mass of this CaCO3. And we are given the mass of this 10.6 gram of Na2CO3. Let us balance this. Okay. So 2 Na, 2 carbon, right? Oxygen. 3, 4, 5, 6, that is 6 oxygen, right? That is balanced here. Okay. So the given quantity, this is the given quantity, this is the given quantity, and this is the asked quantity, and this is the asked quantity. So what is our method? Firstly, to calculate the moles of given quantity and compare it with the asked quantity. Though it has two chemical equations, but it is also a simple question. Okay, see this. Now this is the given quantity. What is the mass of Na2CO3? 23. That is 23 into 2. That is 46 plus 12 plus 64. Right? Okay, plus 48. Right? That is comes out to be 106. Okay, that comes out to be 106. Right? So number of moles here will be this divided by 106, that is 0.1 moles. Okay. Now see this. 1 mole of Na2CO3 is reacting with 1 mole of carbon dioxide. Okay. That means 0.1 mole will require 0.1 mole. If this is the requirement here is 0.1 mole, then only 0.1 mole will be produced here. Right? This means this is also 0.1 mole. If we have to produce 0.1 mole of CO2, then required CaCO3 will be 0.1 mole only. Yes, bacha? Understood this? How you are doing this? This is the given quantity, this is the asked quantity. Firstly, calculate the moles of given quantity. Right? This is the mole of given quantity, that is 0.1. Now compare this with the asked quantity. So now you have, for the given quantity, you have 1 mole of Na2CO3, 1 mole of sodium carbonate is required. Right? It is reacting with 1 mole of CO2. That means 0.1 will be reacting with 0.1. If this is 0.1 mole, this will also be 0.1. If this is 0.1, this is 1, this is 1 mole, this is 0.1, this will also be 0.1. That means the mass, the moles of CaCO3 is going to be 0.1 mole. Right? Okay. So now if they ask you the mass, particles or volume, if they ask you the mass of CaCO3, right? If they ask you the mass of CaCO3 or the particles here, right? Or the particles, or I can say the molecules of CaCO3. Everyone in the comment section write down the molecules here, or the volume of CaCO3. We can calculate everything here, right? By the mole concept. That is, mass will be equals to number of moles multiplied by the mass of CaCO3, that is 100. Right? That is 10 gram. 10 gram is required to produce 10.6. Okay, we can say 10 gram of CaCO3 is required to produce 10.6, to convert 10.6 to completely to sodium bicarbonate. right? Okay. If you want to calculate the moles here, that is 0.1 into Avogadro's number, right? If you want to calculate the volume here, that will be 0.1 into 22.4. Okay, that is going to be the volume, right? Okay. Yes. Okay, that is the right answer. Next we have limiting reagent. Now for limiting reagent, if for example one thing is in excess and the other thing is in excess and the other thing is in the deficiency, other thing is limiting, right? In that case, how are you going to do the questions? Okay, let us see this with the help of an example. Okay. Now you have find limiting reagent. This is the last topic. Yes, this is your last topic of today's. Okay, this is the last topic. Till now, any problem? Yes, easy. Yes. Yes, bacha, don't worry. I am going to firstly let me finish physical chemistry. Okay, then I will surely do inorganic as well. Okay. Yes, bacha. Okay. Find the limiting reagent if 4 moles of N2 gas are reacted with 9 moles of H2 gas. Okay, you have 4 moles. This is N2, H2 is going to give you NH3. Firstly, always remember, right? Balance the given chemical equation here. This is the given chemical equation here. Balance this here. This is 3, this is 2, right? This is the balanced chemical equation here. Write it given. This is write it stoichiometry, or you can simply write given here. Okay, this is given. These are stoichiometry, right? That is stoichiometry. So what is given and what is stoichiometry? Given is 4 moles of N2 and 9 moles of H2. That means 4 moles of N2, 9 moles of H2. Right? That is given to you. And what is stoichiometry? Stoichiometry here is, everyone here, stoichiometry is 1 mole of N2 and 3 mole of H2. That is the stoichiometry here. Now, simple way to answer this question is given by stoichiometry. Given by stoichiometry, that is going to be given by stoichiometry, and here this is given, that is I'm writing it here. Okay, this is given by GS. Okay, this is G divided by S. GS, general science. Okay, that is given by stoichiometry. So this is the given part, 4 divided by 1. This is the given part divided by stoichiometry. This is given out to be 4. This turns out to be 3 here, right? Firstly, given to you in the question, this is given to you in the question that you have 4 moles of N2, 9 moles of H2. You have to calculate, you have to find out which is the limiting reagent. This is a very important question. These kind of questions are asked in your examinations, okay? These kind of questions are asked in your examination. Yes? Okay, perfect. Okay, perfect. Next we have, this is 4 moles, this is 3 moles. Okay, just divide general given by the stoichiometry. You have this value and this value. Here, which will be the limiting reagent? The value that is smaller. Okay, this is the smaller value. This is the smaller value. This will be the limiting reagent. This is going to be the limiting reagent, and this is going to be the excess reagent. Okay, this is going to be the excess reagent, whose value is lesser. Okay, by dividing given by stoichiometry, the value that is less is called the limiting reagent. Here we can say hydrogen is the limiting reagent here. You can also do this with the help of unitary method, but that is very time consuming. Okay, this is a simple method that we have this given, this is stoichiometry, given divided by stoichiometry, you have excess and this is the smaller. Right, now next thing that they can ask you from here, is, I'm writing it here, okay? I'm writing it here that this is 4 and this turns out to be 3. This is given by stoichiometry, right? So now they can ask you various questions from this, okay? That what is the limiting reagent, you can simply say. Or they can ask you after the reaction, After the reaction, what are the moles of N2 that are left? What are the moles of H2 that are left? What are the moles of NH3 that are formed here? Okay. So reaction always proceeds with the help of limiting reagent. So the limiting reagent here consumes always. The limiting reagent is fully consumed here. So this will always be, limiting reagent will always be, this limiting reagent will always have 0 moles, okay. This will always have 0 moles, okay. Or I can say here 0 moles, okay. It will always be fully consumed, okay. This will be consumed totally. The moles that will be left are excess reagent and the products, right? For excess reagent, you have 4, ma'am, how many moles are left here? So now you are given that 4 is the given moles and this is D by S, okay? Simply either you can apply here unitary method, right? Or you can simply write it here that after the reaction, larger value minus smaller value multiplied by the moles of excess reagent in the balanced equation, that is 1 mole left. 1 mole of N2 left. Okay, or I am writing it here, moles of limiting reagent left is always 0. Okay, it is always 0. Moles of excess reagent is always equals to larger value minus smaller value multiplied by number of moles of excess reagent in equation. Okay, that is the number of moles left, right? And when you want to see how much product is formed, right? So you will write it here that 3 moles are giving 3 wait, what you are given here, that is 9 mole of H2 is given to you, right? Okay, so what you will write here, for NH3 you will write 3 moles are giving 2 moles of NH2, right? 3 moles of H2 gives 2 moles of NH3. So 9 moles of H2 will give 2 divided by 3 into 9 moles of NH3. That is 6 moles of NH3. Okay, that is what I am writing here. Number of moles of product formed always compare with limiting reagent, right? Not with the excess reagent, because excess reagent is left behind, right? Limiting reagent is completely consumed here. So you will always relate this with this one, okay? So 6 moles of NH3 will be formed here, right? 1 mole of N2 is left here, right? Okay, so I'll write it here. N2 after the reaction, N2 is 1 mole left, and NH3 formed is 6 moles of NH3, right? That is formed here, right? So now with the moles they can ask you what is the mass of N2, what is the volume of N2. If they ask you what is the mass of N2 left or consumed, okay, or they can ask you mass of N2 consumed, that is 4 minus 1, that is 3 moles. Okay, always see this, what they are asking you, the mass of left NH2 or the mass of consumed NH2. So if they are asking you the mass of left NH2, that will be according to 1 mole, right? If they are asking you the mass of N2 consumed, that will equals to 3 into the molar mass here is 1428, right? This is the mass. The volume of N2 consumed, that is equals to 3 into Na particles. The particles, the molecules of N2 consumed, that is equals to 3 into molecules here are, how many molecules you have? The molecules here are, you have Wait, these are the molecules. Okay. These are the molecules. This is the volume, right? Volume here is 22.4, right? This is the volume. If they ask you how much left, that will be 1 into 28, 1 into Na, 1 into 22.4, right? If they ask you how much NH3 is produced, that is equals to 3 moles, okay? If they ask you mass equals to 3 into this number of moles into mass of NH3, that is 14 versus 70, right? Number of particles, if they ask you molecules produced is equals to 3 into Avogadro's number. The volume will be equals to 3 into 22.4, okay? So they can ask you anything from this, right? Anything can be asked from this. You just need to calculate this one, okay? You just need to remember this thing. Okay, first thing is that you need to remember given divided by stoichiometric coefficient. The value that is smaller is limiting reagent. The value that is larger is the excess reagent. How to calculate the moles of limiting reagent, everyone here, the moles of limiting reagent left will always be 0. The moles of excess reagent will always be equals to larger minus smaller into number of moles of excess. This larger is the value of G by S. This is also G by S. Okay, larger minus smaller into number of moles of excess in equilibrium and the number of product form. That will always be according to the limiting reagent, right? Okay. Yes, I have covered all the possibilities that they can ask you. Limiting reagent to catalyst, yes. So now we have, next thing is, okay, we have done everything here, right? All the parts we have covered here. Next is the concentration, okay? Next part is the concentration that is used in your solution chapter, right? That is used in your solution chapter a lot. Right? Concentration terms will be used throughout your chemistry, right? Throughout your life of chemistry, till the time you are studying chemistry, you have to know about the concentration terms, okay, how they are expressed. So the concentration terms here are, first is mass percentage, okay, always remember for mass percentage, you will always write, for percentage, you will always write solute by solution multiplied by 100. This is in percentage, right? So if you're talking about three things here, we were talking about weight by weight, or we are talking about weight by volume, or we are talking about volume by volume. For weight by weight, this will be weight of solute by weight of solution into 100. Weight by volume, weight of solute by volume of solution into 100. Volume by volume is volume of solute by volume of solution into 100. That is the thing. Right? Okay. Here, weight is always in grams. Okay. Weight is always in grams and volume is always in milliliters. Right? Always in milliliters here. Right? Now, this is the first thing here. Right? Now, if they give you the questions, now how this is used in your examination hall. They will not give you the weight by weight or volume by volume directly to calculate this. No one is going to ask you this, right? What they are going to do, for example, 20% or you can say 25% ethanol, 25% ethanol in 25% ethanol solution, right? So now this is the weight by weight percentage they have given. Now how to decode this? This means they have given you weight of solute, that is 25 grams. Weight of solution, that is 100 grams. Weight of solvent, that is 75 grams. Okay, all these things you can decode from this, right? Okay. Yes, this is going to help because all these things I am going to do in solutions as well. Okay, all these things are basis of solution, all the things that is colligative property, the questions of molarity, because in molality In colligative property, you have elevation of boiling point and depression in freezing point. In that, you use the formula of molality, right? They will not directly give you to you know, make the question more little twisted. What they will do, they will just give you 25% of ethanol. They will not give you directly the weight of solute or the weight of solvent here. Okay, this is how you are going to calculate the weight of solute, the weight of solvent here, right? Okay, so here you can calculate the molality now. You know the value of the molar mass of water, you know the molar mass of ethanol, है ना? So that you can calculate the molality here, right? Similarly, they can also give you one more thing here, that is, if they have given you that this is weight by volume, right? Now you have to calculate the molarity. Okay, I'll tell you how to calculate. What is this given? This is given weight of solute, that is this much, volume of solution, that is 100 milliliters. Okay, this means in 100 milliliters of solution you have 25 gram of ethanol here, right? Now if they have given you volume by volume, that means they will give you volume of solute. If they give you volume by volume, if they give you volume by volume, that will be volume of solute is 25 milliliters. In that case, because this is the same quantity, you can also calculate the volume of solvent, that is 75 milliliter, right? So now, ma'am, how can we use this? How can we use this? See, we have two formulas here, that is molarity and molality, right? Okay, we have two formulas here. Wait. We have two formulas here, that is molality and molarity. Molality means number of moles of solute divided by weight of solvent here, right? That is in kilograms. And molarity means number of moles of solute divided by volume of solution, that is in liters here. Okay, the difference here is that molarity and molality, volume is in liters, in molarity, always remember this by Varun Dhawan. Okay, what is Varun Dhawan? Varun. Okay, so that means volume in case of molarity. Okay, that is, this is Varun, this is R. Okay, this is volume and this is molarity. Okay, Varun, just remember Varun. Okay, this is volume, molarity, right? In molarity we use volume here. In molality, where you have L in place of R, there we use weight of solvent. Okay, here we use volume, Varun, right? This is volume, and this is molarity, right? Okay, in case of molality, what we do? This is weight of solvent here. So for example, here they ask you to calculate the value of molality. This is very simple for you. Now this is simple for you. Because molality is equals to, that is represented by small m, that is equals to weight. Always remember, in solution chapter also I will tell you that for 2 I will always denote 2 for solute, right? And 1 for solvent, right? Okay, 1 for solvent, right? Okay, so this molarity is equals to number of moles of solute divided by weight of solvent. Weight of solvent means W1. Okay, this is total weight, this is W2 and this is W1, right? Okay, so this is weight of this, multiply by 1000. If W1 is in grams here, if I say molality equals to W2 by M2 into W1, here I'll say W1 is in kilograms here. Okay, everything else is in grams. Okay, yes bacha, normality also we are going to do here, normality also. Yes? But you can send me the question, okay? You can send me the question either on Telegram channel, you can write it down in the comment sections, right? Okay? Yes? Yes. Okay, now next thing that we have is the mole fraction. Mole fraction is, for example, you have n number of components here. Okay, you have to calculate the mole fraction of nth component. For nth component, what I will say, you have to calculate the, for example, here we have two components, A and B. I have to calculate the mole fraction of A. Here I will write it number of moles of A component divided by total number of moles in that mixture. That is number of moles of A plus number of moles of B. For mole fraction of B, that will be equals to number of moles of B component divided by number of moles of A component plus number of moles of B component, right? In division, we have total number of moles here. And always, the mole fraction of all the components present in the mixture is equals to unity, right? That is always equals to unity. You will use all this in your solution chapter, okay? In solution chapter, you are going to use this, right? Okay? Yes. Next, bacha, that is the dependency here. Now, what is temperature dependence? Always remember one thing, which has, always remember, temperature is dependent on volume, right? All the formulas of concentration which has volume. For example, molarity has volume, right? So molarity will be temperature dependent, okay? Molarity will be temperature dependent. All the quantities that do not have volume in their formula. For example, if I write here weight by weight. No, let's talk about molarity here, okay? Molarity is temperature independent, okay? It does not involve, it is temperature independent. Now tell me, I'm writing few formulas here. Weight by weight, weight by volume, volume by volume, right? Okay. So out of this depends on the volume, this depends on the volume, this is going to be temperature dependent, okay? This is going to be temperature independent, okay? Temperature independent. If I talk about mole fraction, okay, mole fraction. Now this does not involve any volume in the formula. That is temperature independent. This is temperature independent. Right? Okay. Yes, bacha. Very good. Yes, bacha, I'll definitely solve that. Okay, I'll solve. Don't worry. Okay, firstly I need to clear the concepts here. After that, I am going to conduct a different lecture for only PYQs. Right? Okay? Yes. Next, bacha, we have one more thing, that is ppm. That is ppm. Now, ppm is parts per million. For ppm, you always write solute and always write solution. But this 10 for percentage you write 100. And for ppm, you multiply this by 10 raised to power 6. Okay, that is parts per million. In million, you are saying just one part of it. That is very small amount. Okay, for percentage, percent means cent is 100. Okay, cent means 100. Percentage, we always multiply this by 100. And for ppm, we multiply this by 10 raised to power 6. That is, if I am talking about weight by weight, that will be weight of solute by weight of solution into 10 raised to power 6. If I am talking about weight by volume, that will be weight of solute divided by volume of solution into 10 raised to power 6. If I am talking about volume by volume, that is volume of solute divided by volume of solution into 10 raised to power 6. Yes, bacha? Okay, perfect. Next, we have dilution. There are 2-3 more formulas for this, right? For example, you have a beaker. Okay, you have a beaker. Here you are adding. This is some solute here or some solution here, and here you are adding water. You are adding water here. If you are adding water, the number of moles of that solution, of that number of moles of that solution, that will be same. But because of addition of water, the total volume is going to increase here, right? The volume will be different, but the number of moles of that solute is going to be same, right? And number of moles, bacha, as we know, molarity is equals to number of moles by volume. That means the number of moles is equals to molarity into volume. Number of moles is equals to molarity into volume. So if we say that number of moles is going to be same, I say N is equals to M1 V1 and N2, that is after dilution, it is going to N2 V2. Number of moles I am saying same, that is N1 is equals to N2. That means I am saying M1 V1 is equals to M2 V2. Okay, that means M1 V1 is equals to M2 V2. Right. Next we have for mixing of solution. Now I have one beaker and the other beaker. Okay, I am mixing. This is the first beaker, this is second beaker. This is M1 V1, this is with molarity M2, this is with molarity M2, and this is with volume V2. Right, this is M1, this is V1. So here I will say the total mixture, if I am mixing these two, if I am mixing these two, it is having M1 V1 also, it is having M2 V2 also. What is the total molality here? Okay, the total molality is going to be M1 V1 plus M2 V2 divided by V1 plus V2. This is the molality of a mixture. This is the molality of a mixture. Yes, okay, that is the molality of the mixture. Yes, bacha, I am going to do normality also. See, we are going to do normality also here. Just give me a minute. Yes. Okay. So, normality you will use also this in so many other, parts of your paper. You will use normality also, right? That is not given in your syllabus directly, but you have to know normality because there are so many formulas that involve normality, right? So, for normality, we have few questions, right? Normality is equals to, normality is molarity, right? There's just difference of that n factor here, right? This difference of that n factor. For example, I am talking about normality. Molarity is equals to number of moles by volume of solution. Normality is equals to, here we will replace number of moles by number of moles to number of gram equivalents. Okay, so that is number of gram equivalents divided by volume of solution. That is normality, represented by capital N here, right? Normality. Now what is number of equivalents? This is number of moles multiplied by n factor. Now ma'am, what is n factor here? For example, I am talking about H2SO4. This is giving us 2H positive. N factor, we will also learn this in redox reactions in detail, right? Okay, we are giving it 2H positive. It is giving us 2H positive. So now it is giving us 2H positive, right? This means the n factor here is 2, right? The n factor for HCl, we say it is giving us 1H positive. The n factor here is 1. Okay, the n factor here is 1. Right? So that is number of moles into n factor. Normality is equals to, directly the formula is normality is equals to, this is nothing but molarity, is equals to molarity into n factor. Right? Okay? Yes, bacha? Now see this. We are talking about HCl. For HCl, that is giving us, if n factor is equals to 1, then normality is going to equal to molarity. Okay, so what is the value of n factor? Let us see. Okay, what is the value of n factor here? If we are talking about an element, the valency that it has. Okay, for example, I am talking about Al. Aluminium has valency 3. It means it is going to lose 3 electrons whenever it is in some chemical reaction. So I'll say for an element, it is going to be, valency is going to be the n factor. If I'm talking about the iron, the charge on it is going to, for example, I'm talking about Cu2 positive, that 2 is going to be the valency here. I'm talking about H positive, 1 is going to be the valency bond. In case of iron, the charge on it is going to be the valency. In case of a salt, if I'm talking about Na2SO4, right, it is going to give us 2 Na positive plus SO4 2 negative. That means the charge total here is, here we have 2 positive charge, 2 negative charge. So 2 is going to be the valency here. N factor is going to be 2 here. Right? That is total positive or negative charge. Right? Next we have acid and bases. For acids, the number of H positive, the acid is the basicity. That means if I am talking about H2SO4, right? It is giving us 2H positive, and these 2H positive are going to neutralize with 2OH negative. That means the basicity of this acid is N is equals to 2. 2 is the basicity. That is how much H positive is going to neutralize with the base. So it required 2H positive here to get neutralized here. So I'll write N is equals to 2. So value of N is going to be 2 here. Right? Okay. Yes. Now, bacha, some important thing for you. We have completed the chapter here, right? So the important thing for you is that all the links, okay, all the links are provided to you in the chat box here, in the description box here, right? That is NEET 2024 treasure box is provided to you. There you will find the PYQs, NEET PYQs, CBSE PYQs, everything, right? NCERT solutions, year-wise PYQs, chapter-wise PYQs, everything will be provided to you. Also, the notes will be provided to you with the YT link, okay? Now, next is the Telegram channel. Now, let me show you this, okay? Let me show you this. So, see here. For example, I am talking about this one, okay? I am talking about this one. So, we have some basic concepts of chemistry. So, just add on to this, okay? Sign up with your ID, okay? Any ID that you have, okay? It is asking me for the mail here, right? Wait. Let me switch to my account here. Just give me a minute here. Just give me a minute, beta. Just give me a minute. Just a minute, okay? Yes. Just a minute. Okay. So guys, yes. Okay, see this? Very important. Now, if I talk about your scholarship here, just go to this IVSAT, right? Submit your number here and OTP will be sent here, and then you can enroll to IVSAT scholarship. And for IVSAT scholarship, what we are going to provide you, that is, we are going to provide you according to your rank, we are going to provide you the scholarship, right? For all the students who want to have scholarship, right, they can give this test, and based on your test result you will be provided the scholarship. If you are giving the test in offline form, then you will be provided with 2x amount of the scholarship. If you are like far away from the centers, then you will given with the x amount of scholarship, right? Okay, next bacha that we have on this lecture, I'll give you one most difficult question, okay, on this topic, and one most twisted question based on this topic. So for that, you just need to click down and you will get that question, okay? I'll give you the answer there also, right? Answer will be provided to you, question will be provided to you. That is going to be your homework, right, everyone? Okay, and one student was saying One student was saying something, molarity. What about normality? This, okay. Okay, for phosphoric acid, yes. But don't worry, I am going to do that in redox reaction. Okay, we are going to do that in redox reactions. Okay, N factor, we are going to cover that in detail. Yes, okay, okay. Okay then, bacha, now my request to you is that you must go through this one, okay? Go through this most difficult question and go through the PYQs here. Okay? The PYQs you will be provided here, okay? Some basic concepts of chemistry, PYQs test you will be provided here, right? PYQs test, right? You can start your test here, right? And here you can give the answers, okay? The questions, these are all previous year questions, okay? Next, bacha, that we have, for example, right, required for this, the number of hydrogen moles required in this limiting reagent, right? Falling maximum and minimum. What is the falling has maximum number of atoms, right? All these are PYQs. And as you have just done the revision of your some basic concepts of chemistry, best part will be to give the PYQs test straight away, right? Next thing that you need to do here is NCERT solutions, okay? So these are the NCERT solutions, okay? Go through the NCERT questions as well. You are given with the solutions, right? You can go through the questions here, right? Okay, everyone? Yes? PYQs test, then PYQ solution you will be provided, right? And then NCERT questions. Do this after the session so that we can complete one chapter fully fledged. Right, okay. Now the next chapter, this was a very easy peasy chapter, right? A very easy peasy chapter. That is why students were so less here, because it's a simple chapter, right? Next chapter that we are going to do is structure of atom, right? Structure of atom, starting from the very start to the end, starting from the theories, Bohr model theory, Rutherford theory, all the questions that are asked from those, then jumping to the quantum numbers, right? Doing all the calculation based, very simple question of quantum number are asked in your, right? And also one more thing that is asked, that is important for your this NEET examination is graphs of radial, antinodal, all those graphs, okay? The graph of quantum numbers, the graph involving Schrödinger wave equation, right? So for all those graphs, we will do that in the next session, in the next lecture of structure of atom. Yes, everyone? Yeah, I'll feed him. Don't worry. I'm going to feed him, okay? Don't worry. Dogs are... dogs are very precious to me also. I take care of them like my own bachas. So yes, they're asking for food. Yes, bacha. Okay. Chalo. Hare Krishna. Okay. Yes, bacha, I'll be doing more chemistry sessions now, starting off with physical chemistry, and few of the important sessions are coming for you regarding your PYQ session, and most important questions on all that we will be covering, right? Okay? Okay then, bacha, bye-bye, take care now. Please revise this, a simple chapter. Do not, this is a simple chapter. You will easily get full marks from this. 2 questions will be asked from this chapter, right? But this chapter is going to, be a big part in your different lectures. Like in electrochemistry, you will find the use of this chapter. In solutions, you will find the use of this chapter. Electrochemistry and solution, you will find a lot of questions that are based on some basic concepts of chemistry. So please revise this yourself also. Okay then, bacha, bye-bye, take care. Yes. Okay then, bye-bye, take care. See you all in the next session. Bye-bye, take care.